Okay, now I'd like to tell you about something that you're all going to be doing in your dissertations, which is hypothesis testing. And in its simplest form, hypothesis testing is when you have two hypotheses. The null hypothesis, which states that there's no difference between the groups that are separated by your independent variable. Let's just reference the study I was talking about most recently with the IQ scores of sex offenders. The null hypothesis would be that there's no difference between sex offenders' IQs and the IQs of the general population. Whereas the alternate hypothesis would be that there is a difference. Now notice that the way this is stated, I'm not saying that I hypothesize that sex offenders are going to have a lower IQ or a higher IQ. I'm just saying that they are not going to be equal to the population. Now when you do hypothesis testing, you are always vulnerable to making an error, okay? And I want you to just take a look at this table for a moment. Here we have the decision that you make based on your sample statistic. So you run your subjects and you collect your data and you come up with the mean from your group of subjects, and you ask the question, are these subjects significantly different from the population? Okay, so this is the decision you make, and you might make the decision to accept the null hypothesis, which is that there's no difference, or to reject the null hypothesis, indicating that there is a difference between the groups. Now, this is something that we can never know for sure, but let's just say that we could know it. What is the true state in the world? And let's say that we know, for example, that the null hypothesis is true, that there's no difference between the groups, or we know that the alternate hypothesis is true, that there is a difference between the groups. Okay, there are four possible situations that could occur when we run our experiment and come to our conclusions. The first one that I want to talk about is when the null hypothesis is what you decide to accept, and it turns out that the null hypothesis is true. And so you correctly say there's no difference between sex offenders and the regular population in terms of IQ. Another possible correct statement that you could make is that you reject the null hypothesis, that there's no difference, because in reality, in the world, there is a significant difference between sex offenders and others on IQ. And that would be then a correct decision to reject the null hypothesis. Either way, you're right, and that's always a good thing. Now, there are two potentially wrong decisions that you could make. The first one is type 1 error associated with, and I'm sure you're all familiar with alpha, which is almost always in psychological experiments set at 0.05, which basically means that we're willing to accept the possibility that we are wrong as a field 5% of the time. A type 1 error is when you say that the groups are different, but in fact, they are not different, okay? So you're rejecting the null hypothesis incorrectly. Then there's a type 2 error, or it's also associated with, it's also referred to as beta, and this is when you say that there is no difference between the groups, but actually there is a difference between the groups, and that's another kind of error. Now, type 1 error, type 2 error, and something called power are all related to each other. And I love showing students this next slide because I think it's very possible that you're going to have an aha moment right now if you haven't already felt like you understood this. So just really pay attention now as I explain the relationship between alpha, beta, and power, and I'm even going to squeak in a little bit of information on sample size as it relates to power too. Okay? Does everyone see that this line represents the critical value, which means the point at which I'm going to say if the mean is above this line, then I'm going to reject the null hypothesis. If it's below this line, I'm going to accept the null hypothesis. And so as I make the critical value go up, that would decrease alpha. Now remember that I said that in psychology, we usually set alpha at 0.05, which means there's a 5% chance that we're going to say someone is in this group when actually they're in this group. They're just in the tail end of that group, okay? Now, what if I said, you know what? I really don't want to make a mistake here, because that would just have terrible consequences. I could get more rigorous in my critical value and say, I'm only willing to accept an alpha of 0.01. Now, do you see when I move this up like this, what is happening to the area defined as beta, which is your chance of making a type 2 error, which is saying that which is saying that the null hypothesis is true when actually the alternate hypothesis is true. Hopefully what you see is that when you get more rigorous on your alpha level, you're increasing the probability that you're going to make a type 2 error and miss a significant difference between the groups that's actually there, but you aren't seeing it as statistically significant because you've moved your critical value up. Well, what you should also be aware of is that this portion of this curve indicates your chance of correctly rejecting the null hypothesis, and that's called power. As you decrease alpha, as you move the critical value up, you're also decreasing power because you're increasing your chance of making a type 2 error. So you're increasing beta. Okay, so do you guys understand that? You're all hopefully nodding right now and saying, okay, I get that. All right, now let me point something out. If we keep the critical value at 0.05, but we increase the sample size, what that does is it pulls this graph up like this, and I don't know if that's going to be clear from the way I've drawn this, but what's happened is, even though I've left the critical value cutting off 0.05 of the curve, I've drastically reduced beta. Because remember what I said earlier about increased sample size reduces the standard error. And so I hope that if you followed me through this explanation, you have a good understanding of how type 1 error, type 2 error, power, and sample size are all related to each other.